بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته أبناء الأعزاء. Let us continue our discussion for the inverse trigonometric functions. Alhamdulillah, we discussed before the inverse of sine and the inverse of sine minus 1x and sine minus 1x. As I told you before, in the inverse trigonometric functions, we already have the value of the sine or cosine or tan or cotan or sec or cosec, and we need the corresponding angle. Before, when we are dealing with the original trigonometric functions, we have an angle and we are asked for what is its sine, what is its cosine, what is its tan, and so on. But now we have the value of the trigonometric ratio itself. We have the value of sine, and you are asked for what is the corresponding angle. We have the angle of cosine. What is the corresponding value of the angle? We have the value of tan, and what is the corresponding value of the angle, and so on. Now, inshallah, we'll start with discussing the inverse tan function, which we call it tan minus 1. Let us go back to have a simple review for the tan function. As we discussed before, the tan function has its graph like this: x, y. Y equals the original function f of x, which is tan x. Okay, and we know its graph is like this. We discussed this before, like this. As we know, it's periodic of period pi, and also cotan is periodic of period pi. Only tan and cotan are periodic of period pi. Okay, as you see, it is repeating from minus infinity to infinity. These are vertical asymptotes at x equals pi by 2, x equals minus pi by 2, x equals 3 pi by 2, x equals minus 3 pi by 2, and so on. Okay, as we said, if we tried to make the image of this function about the yx line, we will have a multivariate function. All these are repeated, so we consider what we call the principal branch. For the tan function, we consider this part as the principal branch. This part only. This part from minus pi by 2 to pi by 2. This part only. This is the principal branch of tan. As before, we took the principal branch of sine x is from x equals minus pi by 2, x equals pi by 2. And for cosine, we choose the part from 0 to pi as a principal branch for values from x equals 0 to x to pi as a principal branch of the cosine. Now for the tan, we consider only this is a principal branch which we will consider to obtain the inverse of the tan function. Still, this is tan x. Now, as we said before, when we obtain the inverse function, every vertical line will be transformed to horizontal one. This line was x equals pi by 2. This one x equals minus pi by 2. Now, for the inverse function, y equals f minus 1 x, which is tan minus 1 x, would be like this. This vertical line x equals pi by 2 will be transformed to y equals pi by 2, and this one x equals minus pi by 2 will be transformed to y equals minus pi by 2, as something like this. This is now y equals pi by 2 as the image for x equals pi by 2. Another one, y equals minus pi by 2 as the image of x equals minus y by 2. and the graph of tan minus 1 will be like this. As we know, tan x was odd function, also tan minus 1x is an odd function. As we know, the domain of x was from minus infinity to infinity, except at the points which makes the function tan infinite, which are x equals minus y by 2 and y by 2, minus 3y by 2 and by 3y by 2, and so on, which are multiples, odd multiples of y by 2. So the domain is from minus infinity to infinity for x, except 2n plus 1 times y by 2, where n is 0, 1, minus 1, 2, minus 2, and so on. Now, as you see, for tan minus 1, its domain x, this is for tan minus 1. This function is tan minus 1. Its domain x belongs to R. This y equals y by 2. This y equals minus y by 2. Y its range from minus y by 2 to y by 2. Y belongs to open interval minus y by 2 to y by 2, open interval. Symmetry, odd symmetry. Periodicity, none, as we told many times before. Only the six functions, sine, cosine, tan, cotan, sec, cosec, these functions only are periodic, and the functions are not periodic, none. Okay? What about its derivative? Let us calculate it. We have y equals tan minus 1x, which means that y is the angle of which the tan is x. Y is the angle of which the tan is x. Or x is tan y. So we can write x equals tan y. I repeat, take care. This is not 1 over tan. This is not tan x to the power minus 1. No, it is a notation to express the inverse function of tan. Originally tan, this is an angle, this is a value. When you say tan, after tan is an angle. The value of tan, this angle is a number. Now, tan minus 1x means we have a number representing the tan, and we're obtaining y, which is the angle. Now, x equals tan y. This means the x by dy equals sec squared y. Okay? So dy by dx equals 1 over sec squared y, which is 1 plus tan squared y. But tan y is x. So dy by dx equals 1 over 1 plus x squared. This is the inverse of d by dx for tan minus 1x. Okay? Take care. d by dx for tan minus 1 any function equals 1 over 1 plus this function squared times the derivative of that function with respect to x. For example, d by dx for tan minus 1 x squared plus sine x equals 1 over 1 plus x squared plus sine x all squared times the derivative of this function, which is 2x plus cosine x. Okay. This is for the inverse of tan x. Okay? Someone may wonder, it is difficult for me to obtain the graph of tan minus 1 as the image of tan x relative to the line y equals x. Do you have another approach? Yes, there is another approach. Say this is line y equals x. The image of this curve relative to x is this one. Someone may ask, do you have another approach? Yes, actually we have. What is this approach? This is back, right to left. We will consider back, right to left. What is that approach? Let us discuss it. First, determine the branch which you will consider to obtain the inverse function. For example, for tan, we already know that part of tan which is bounded between x equals minus y by 2 to x equals y by 2. This is the original function, and this is the branch which we will consider in our discussion. X, this is tan x, this is x equals y by 2, this is x equals minus y by 2, and the pressure branch is that part. Okay, what is your approach? Back. Okay, turn the paper like this. Again, use your hand, right hand. Use your right hand. Use your right hand. Turn the page to the back like this. Okay, turn the page 90 degrees to the right. Okay, turn the page 90 degrees to the right. This is the curve you are looking for. Look, this is the curve you are looking for. Now, draw your axis. Draw your axis. Always the horizontal is x. Always the vertical is y. But now we have tan minus 1x. Okay, before this was vertical, it was x equals y by 2. Now it is x, it is y equals y by 2. Before this was x equals minus y by 2. Now it is y equals minus y by 2. Okay, with a heavy line. This is the new graph you want, as we obtained before. The same as we obtained before, as you see. Same graph. Okay, we'll start it again, inshallah, when we're dealing with cotan minus 1. Few seconds, inshallah, coming. Now, it was a function y equals cotan minus 1x. The inverse of cotan. Before originally we were studying y equals cotan x, where x was an angle. This is a value. For example, y equals cotan pi by 4, which is 45 degrees, which is 1. So we are given the angle, we calculated its corresponding cotan. Now we are asking for what is the angle for which the cotan is 1. What is the angle for which the cotan is 1? This is what is the angle for which the cotangent is 1 or equals 1. Okay, as we know, it's pi by 4. Cotan minus 1 is pi by 4. So now when we say y equals cotan minus 1x, now x is a value and y is an angle. Okay, let us continue in the same way. We studied before the graph. As I told you many times, without the graph of the function, we are lost. Especially for the basic functions. 28 basic functions. Remember? Do you remember? We have for cotan x, vertical line at x equals pi, x equals pi, x equals 0, x, this is the y-axis, which is x equals 0, and a third vertical asymptote at x equals minus pi. Every pi will have a vertical asymptote. Okay? And its graph was like this. As you remember, this is tan x, cotan is the reciprocal. When this is 0, cotan is infinity. When this is infinity, cotan is 0. So the curve of the cotangent is like this. This is cotan x. We consider only that part from 0 to pi as the principal branch. This is the principal branch, this part, for which we will obtain the inverse function. Okay? This is the principal branch. Okay? X, y equals cotan x as you see. We'll take it away. Okay, now we need the graph for the inverse function y equals cotan minus 1x. As we said, turn the paper, it's back like this, turn 90 degrees to the right like this. This is the required graph. Again, turn the paper to the back, turn to the right, not to the left. We said right to left, right to left, okay? And turn to the right. This one. Don't make it in one step, please, in 2 steps. To the back, then to the right. Please, 2 steps. First step to the back, then to the right. Don't make like this. Okay? to the back, to the right. Okay. We can simply say back to right. Simply. Back to right. Back to right. Okay? This is now, it was y-axis, now it is the x-axis. And we have now a horizontal asymptote rather than a vertical one as before. Okay? Now this was the x-axis, is now the y-axis, and y equals cotan minus 1. And y equals cotan minus 1x. This is 1. Okay? This was x equals pi, it is now y equals pi. So, two asymptotes, y equals 0, y equals pi, and the required graph for cotan minus 1 is like this. Before, this point was x equals pi by 2. It is now y equals pi by 2, which is 0 and pi by 2. Okay? This is our function. As you see, its domain x belongs to R. Its range y belongs to open interval from 0 to pi. Symmetry, none. Okay? Periodicity, many times we said none. Periodicity only for the original 6 trigonometric functions, sine, cosine, tan, cotan, sec, cosec. What about its derivative? Very simple. We start with y is the angle of which x is its cotan. Y is the angle of which x is its cotan, or x equals cotan y. Okay? Differentiate dx by dy equals minus cosec squared y. So dy by dx equals minus 1 over cosec squared, which is 1 plus cotan squared. But cotan y is x, minus 1 over 1 plus x squared. The same like that. You remember? Before we had y equals sine minus 1x, its derivative y dash is 1 over square root 1 minus x squared. Y equals cosine minus 1x, y dash equals minus 1, the same but with negative sign. Now, our current lecture, y equals tan minus 1x, we have y dash 1 over 1 plus x squared. And few seconds ago, we had y equals cotan minus 1x, for which y dash the same like cotan minus 1, but minus 1 over 1 plus x squared. Inshallah, we'll prove, when y equals sec minus 1x, y dash will be, we'll deduce it as 1 over x plus x squared minus 1. If y equals cosec minus 1x, the same like this but with negative sign. So you have to keep in mind only 3. This one, this is similar to it but with negative sign. This one, and this similar to it but with negative sign. This one, and this similar to it but with negative sign. Okay? So y equals cotan minus 1x has derivative y dash minus 1 over 1 plus x squared. Generally y equals to 10 minus 1 some function, y dash equals minus 1 over 1 plus this function squared, the function by dx. We'll stop here, and inshallah next lecture we will discuss sec minus 1 with inshallah some important solved example. Wassalamu alaikum wa rahmatullahi wa barakatuh.